Welcome to Moth Magic, Part 2, introducing you to the diversity of moths. So far in the series we've looked at what is a moth, and after the diversity we're going to look at survival, ecology, conservation, and how to get involved in recording moths. Now then, diversity. What are we going to have a quick look at today? Well, as quick as possible anyway. We'll have a look at the family tree for the moths, give you some idea of why there are so many families. Have a look at how the species are distributed, looking at global, continental, regional, and local examples. And we'll have a quick look at area-specific taxa that look similar to each other and gives you a little bit more diversity, the concept of endemic taxa, and the concept of cryptic species, all of which go together to boost the numbers of species of moths. But what I do want you to pay attention to throughout all of this, ask yourself, how does Homo sapiens impact upon all this diversity? Right, relationships, the family tree. Moths turned up something like 300 million years ago, at the beginning of the Permian. That's a long, long time ago. This information's only really been put forward in the last few years. Kawahara et al., 2019, only 2 years ago, published this paper. And from the illustration, the family tree, we can see here the timeline, the Jurassic Cretaceous boundary, 140 odd million years ago, is roughly where the butterflies and moths started really taking off in terms of major diversity. Incidentally, butterflies are far more primitive than more than half of the moth species. Even half of the moth families come to that, evolving about 90 million years ago. Stuck with the micromoths, for those that know their differences between macro and micro. And then there's the carry on over the second page. So the butterfly is right at the top. And then the Macrolepidoptera in the last major clade, with the hook-tip moths, the owlets, the geometrids, lappets, and the bombicoids, as the emperors, the hawks, and the silk moths. The radiation of that last major group, the Macrolepidoptera, in effect taking place between about 80 and 40 million years ago. So over the 120 odd families, just 5 of those are butterflies. Now, distribution. Globally, we have something like 160,000 species of moth described, with a further 150,000 to 200,000 by most counts estimated. But there's a big divide in the way these species are distributed across the world, into the Americas or the New World, and combination of Europe, Asia, Africa, and Australia, the Old World. And this divide reflects current distribution, but of course, if we turn the clock back to the historical, prehistorical, evolutionary thinking, then South America was joined with Africa, was joined with India, was joined with Australia and Gondwana, around the time that butterflies and moths were undergoing their major diversification. The other major factor that impacts the diversity as we see it is actually the recording effort. So in areas where people have been recording butterflies and moths a long time, that means post 1700 or so, we have quite a good understanding of how diverse the fauna of those continents are. Whereas more diverse areas have less recording. So we've got quite a way to go. Let me show you. For North America and for Europe, we have 11,000, 10,000 species approximately, respectively. And that's a fairly accurate figure based on lots and lots of recording. We'll come back to that later. However, with probably the exception of Japan and perhaps 1 or 2 parts of Southeast Asia, most of Asia has not been well recorded. In spite of that, we've got over 50,000 species here. And yet, that's probably not even halfway to where we're going. South America, the story is similar, with one or two spots that are well recorded, but overall, the figure of 40,000 is likely a woeful underestimate. Africa is even more of an unknown quantity, 30,000 or so species to date, but probably more than double that. Last off, Australasia. We have at least 14,000 species, only half of which are described, and probably more to discover yet. So of that 160,000, and these figures add up to 160,000, not accounting for overlaps between areas, which is not that much. That extra 150 to 300,000 is going to be made up mostly from Asia, Africa, and South America. Now, take a closer look at Asia. For India and for China, both of those large countries with many, many habitats are estimated to have something in the region of 20,000 species each. Some overlap, but not that much. Further to Southeast Asia, well, in Hong Kong, we have 2,500 species documented and probably as many again awaiting discovery. Taiwan has at least 4,000 species. In Peninsular Malaysia, 6,000 species from 40 years' work at Genting Highlands, and just in 3 years at Fraser's Hill, 2,500 species, of which here are some. But if so many species in such a short period of time, the estimate for Borneo, based on the Moths of Borneo series for the Macrolepidoptera and for the work being done on the Pyraloidea, is currently at 8,000 species, 500. But that is maybe a large underestimate. We're not really sure, but we can expect it given the figures for the Peninsula Malaysia. Okay, let's look at somewhere that's been well documented. Go back to Europe. We know France, Germany, and the UK have a very long history of documentation of Lepidoptera. So the figures of 2,500 for the UK is fairly accurate. They add a few species every year, but it's not lots and lots and lots that are missing. The same for Germany at 3,500 and for France at nearly 5,000. How do we know that? Well, projects like the UK, larger moths have county recorders, and under each county, lots of people, sometimes maybe even 50 or 60 people, recording moths on a regular basis so that we can actually distribution map to 10-kilometer grid resolution for all the UK. Not for one or two moths, but for all of the larger moths. So out of the 950 odd moth species in the UK, each 10K grid has a known fauna. We can dream in the rest of the world to cover that, but we need the people on the ground to help out with that. And that is where something like National Moth Week comes into play, because it gets people out on the ground worldwide to help improve the coverage and understanding of how moths are distributed. In North America, we have figures for the USA and for Canada. But if you recall the first slide where we had 11,000 in North America, most of those are actually the United States. The 5,000 species of Canada overlaps almost totally with the USA. So actually, the 5 plus 11 is not 16, it's still 11. But compare those land areas to somewhere like tiny little Costa Rica, which has 12,000 species and counting. In fact, most of those 12,000 species is the work of one person, Dan Jansen, at one site. The same story in Colombia and in Ecuador. Many thousands of species based on the work of just a very few people at very few sites. So the estimates here, like Borneo, are woefully under what is likely to actually be there. Now, an example of Old World versus New World. groups that look superficially similar and are sort of related, at least they're within the same tribe of moths. The Old World Theritra and Hippotion. Notice here that I've actually got these the wrong way around. That's my mistake, but it keeps me on my mettle. Against the New World genus Xylophanes. So let me show you. This is the New World genus, and they're fairly varied in their pattern. But in shape, they're pretty consistent. The problem is that because the pattern components in color and in line elements are quite variable between the species, and because of the way iNaturalist, one of the NMW partners, has its artificial intelligence recognition for identification based on visual elements, it gets confused between this just as much as people do. So this old New World genus distributed in tropical and subtropical Americas. There's one species record here from Taiwan, which is a misidentification of a Theritra, and they look unsurprisingly similar. But they're old world. They're in Africa, they're in southwest Europe, they're throughout Asia and down to Australia, as is the sister genus Hippotion, which again looks similar, they are slightly smaller. Also, same distribution, actually slightly more extensive. They're throughout the Mediterranean rather than the southwest only, throughout Africa and throughout Asia, but again confined to tropics and subtropics, with the exception of southern Australia, actually through to Tasmania, and the north end of New Zealand. Incidentally, Hippotion and Theritra are great travelers. There are a number of migratory species within these two genera, and have even reached the very isolated island chain of the Hawaii complex. Now, talking about islands and geography, the concept of endemic species is another component, the magic of speciation and of species counts. An endemic species is a taxon whose distribution, basically, taxon being species, family, genus, subfamily, tribe, superfamily, restricted to a particular geographic area. So that could be a continent, it could be a country, it could be an island, it could be a state, it could be a province, and so on. So this example we're showing here is the genus Urania, the sunset moths, of which the original species, if you like, at least the most oldest in the evolutionary tree, the family tree of the Uranidae, or which comprises Urania and allied genera, comes from Madagascar, whereas the rest of the species come from the neotropics, that's tropical Americas. And there are 2 points here. The first is that Madagascar is a long way from South America, but it hints, as I mentioned earlier, about the connectivity between South America and Africa through Gondwana, from the connections in the beginning of the Cretaceous. So Urania has evolved into at least 4 species, one of which, represented by the dark and light green circles, is in South America, south of Colombia, Venezuela, and the Guianas. There's a second species which is throughout Central America and into the Caribbean. And then there are 2 endemics. One is endemic to Cuba, Urania bordevallei, and one which used to be, because it's now extinct, endemic to the island of Jamaica. It's Urania sloanus, after Sloane, you think of Sloane Square in London, and you'll get the message of who it's named after. But the problem we have with endemics is that because of human impact, just like Sloanus, species are at risk of extinction due to human exploitation of habitat. And as Sloanus was a lowland tropical species, the lowland was cleared for agriculture. It went bye-bye by the start of the 20th century. Now, where does that lead us? One other group of species, the cryptics. Cryptic species is maybe where we find even more species that we haven't found yet. Let me give you an example that's actually hot off the press just earlier this year. There's a group of what we call handmaiden moths. The genus Amata, or perhaps Syntomis, but that's a moot point here and not one that I will delve into, is a group of day-flying moths that look, at least in this complex, superficially identical in the field. All black background, two yellow bands, one across the abdomen at the base of the thorax and one near the end of the abdomen, and then white spotted forewing and hindwing. So to anybody casually walking around by day, these are day-flying moths, these guys look the same. But analysis of the genetic makeup, analysis of the pheromones used, that's the perfumes used for females to attract males, shows that these are different species. They occur in the Mediterranean, and mapping them shows that we have some widespread species. So Phrygia, which is the one that actually goes right the way through to Central Asia, is the common one, widespread, and previously thought to be part of the Phrygia group, but now distinct in at least 4 species ranked taxa, but perhaps more, because the genetic analysis shows there are subgroups within the species. There are a number of species within the same distribution of Phrygia, some restricted to Italy, some restricted to the Balkans and then further east north of the Black Sea. So the use of genetic work is really opening up our current understanding of how diversity of the Lepidoptera, not just the moths, but butterflies as well, is being revised quite radically in terms of understanding that our missing 300,000 may even be an underestimate. But what this also illustrates is the presence of endemic species, and we have endemics in Italy here under Quercii and Ragazzae, plus cryptics in this whole Syntomis / Amata Phrygia group, highlights the plight of not just Lepidoptera but all nature, and the key concept of conservation for all life, to keep not just humans going but everything going on the only planet that's around within reasonable travel distance at least that supports life. Now then, that's a quick revision. What have we looked at? We've looked at how rich the Lepidoptera, particularly moths, are as a group of insects. 150,000 described, maybe another 300,000 or even more awaiting discovery and description. They're found throughout the terrestrial world, except the Antarctic, which is just a little too cold. Each continent has its own distinctive composition of species and, in fact, higher taxa. So even at family level, there are some families that are endemic to particular continents. A lot of species illustrate extremely limited geographic distribution. It's very high endemicity. New Zealand, for example, 90% of its moth fauna is only found in New Zealand. Okay, that's a wrap for the diversity. Coming up in part 3, we'll look at how the magic of color, species, patterns, and shapes is used to survive. That's all from me for now, and we catch up with you next time. Thank you very much.